Hello Year 10 Mathematics 5.3 students. Today we're moving on in the properties of geometrical figures topic to polygons. So a polygon is a plane figure with straight sides, and it's said to be regular if all of its sides and angles are equal. If they are not, it is said to be irregular. Some polygons are named according to the number of sides. So a regular hexagon is named a hexagon because it has 6 sides, and hex means 6. An irregular hexagon is named this because not all sides are the same. And then we have a concave hexagon. So a polygon can be concave or convex. In a convex polygon, all the interior angles are acute or obtuse. So a regular hexagon, this regular hexagon is a convex, and so is this irregular hexagon, it is convex because all of the interior angles are acute or obtuse. In a concave polygon, at least one of the interior angles is a reflex. So this is a concave hexagon. Angle sum of a polygon. We can use the result for the angle sum of a triangle to work out the angle sum of a polygon because all polygons can be divided into triangles. Now we're going to investigate it. We're going to divide each of these polygons into triangles by drawing triangles from one vertex. The quadrilateral and pentagon have been done for you. So if we have a look at our quadrilateral, if we start at one vertex, we draw a diagonal across. We can't draw to any other vertex because we would not be drawing a diagonal. We'd be just going along the edge. For our pentagon, we can go to this one and this one. I want you guys to stop the video for a couple of seconds and have a go at doing it yourself. Okay, hopefully you're back and you have already drawn all the triangles on your hexagon, heptagon, octagon, and nonagon. So for your hexagon, you should be able to draw 3 lines. For your heptagon, you should be able to draw 4 lines. Your octagon, you should have 5 diagonals, and your nonagon you should have 6 diagonals drawn. Now I want you to sketch a decagon, a 10-sided shape, and a dodecagon, a 12-sided shape, and then divide them into triangles. So pause the video here, have a go at doing it yourself. 1, 2, 3, 4, 5. Alrighty, hopefully you've come back and you have drawn a decagon and a dodecagon exactly like I have. So now we're going to break these up into triangles by starting at this vertex here on our decagon. So we have 1, 2, 3, 4, 5, 6, 7 lines, and then we'll start here on our dodecagon. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now what we want to do in part 3 is use the results of our work to complete the table of the number of triangles. So the number of sides in a polygon is 3. The number of triangles was 1. For our quadrilateral, it was 2 triangles. For our pentagon, it was 3. For our hexagon, we have 4 triangles. For our heptagon, we have 1, 2, 3, 4, 5 triangles. Oops. For our octagon, we have 1, 2, 3, 4, 5, 6. For our nonagon, we have 1, 2, 3, 4, 5, 6, 7. So we had 1, 2, 3, 4, 5, 6, 7. For our decagon, we have 1, 2, 3, 4, 5, 6, 7, 8. If we had an 11-sided shape, we'd have 9, because for our dodecagon, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles. So we can use this information to write the angle sum of a polygon's formula. So the angle sum of a polygon is calculated using the formula of the sum of the interior angles equals the number of sides we call n minus 2 times 180 degrees. Now the reason we use 180 degrees is because there's 180 degrees in a triangle, and we use n for the sides of the polygon and 2 we take away. As you can see here, the difference between all of these numbers is 2. Moving on to the exterior angle sum of a convex polygon. An exterior angle of a polygon is an angle that forms a straight line with one of the interior angles, like you can see here. As you can see there. So if the interior angle is a reflex angle, then no exterior angles exist, like here. So the angles in a convex polygon are acute or obtuse, so a pair of interior and exterior angles will exist at each vertex. The sum of the exterior angles of a convex polygon is 360 degrees. So that means that all of these angles here are going to add to 360 degrees. Let's have a look at some examples and then you can get stuck into the work. So we want to find the sum of the interior angles of an octagon and the size of an interior angle if the octagon is regular. So we're going to use our formula for the sum of interior angles. So the sum, we're just going to say S equals n minus 2 times 180 degrees, where in our case, our n is going to equal 8 because there is 8 sides of an octagon. So let's sub that in. So we'll have S equals 8 minus 2 times 180 degrees. So S equals 6 times 180 degrees. So S will equal 6 times 180 degrees, which is 1080 degrees. So the sum of all the interior angles of an octagon is 180 degrees. So, therefore, the size of one interior angle can be calculated by dividing by the sum. So we divide our sum, so our 1080 degrees, divided by the number of sides that we have. So when we put that into our calculator, we will get that this interior angle of one angle in our octagon is 135 degrees. And so the way we did this is we went the sum over the number of sides, which we have said in our formula that the number of sides is n. Okay, so our sum, our answer, over the number of sides. Example 2 says a regular polygon has an exterior angle of 20 degrees. How many sides does the polygon have? So the sum of exterior angles is 360 degrees. So to work out the number of angles, all we have to do is go, well, the number of angles, what we have to do is go our 20 degrees, our sum of exterior angles, so 360 degrees, divided by 20 degrees, and we will get our answer of 18. So how we calculated that was, it is the sum of exterior angles over how big one exterior angle. So over one exterior angle, and we get 18. So if you're following the Australian Signpost Mathematics New South Wales Year 10 Stages 5.1 to 5.3 textbook, you would now have a go at doing exercise 306. Have a great day.